In this video, we will compare the capability of two sandboxing solutions, Palo Alto Networks' WildFire and Check Point's SandBlast, in preventing both known and unknown malware. First, let's take a look at Palo Alto Networks' WildFire. From the Support Portal user account, we log into WildFire Portal and browse to Upload Sample section. For this example, we will upload two sample infected files. The first file, sample3.pdf, infected with known malware, was downloaded from the VirusTotal website. The second file, makingleaderssuccessful.pdf, is infected with unknown malware. This type of malware takes advantage of a known exploit by using advanced evasion techniques and return-oriented programming, more commonly known as ROP. As we can see after uploading both files, they are found to be benign by Palo Alto's WildFire solution. Let's dig a little deeper to make sure the correct files were uploaded. First, let's compare the MD5 hash and verify that the same file was analyzed by both WildFire and VirusTotal. The MD5 hash for sample3.pdf is verified locally. Now, let's verify the same file on the VirusTotal website, where this malware file was originally downloaded. As we can see in the results, 31 out of 55 engines find this file to be malicious. And just to be sure, let's compare MD5 hash again and see that it is the same file. Now, let's move on to the second file, the one that contains the ROP and advanced evasion techniques. We can see that in WildFire, this file is identified as being benign as well. By running its evasion code, the malware evaded detection. Once again, comparing the MD5 hash, we can see that this is the same file. Again, only static analysis was done on the infected file, which incorrectly categorized the file as being benign. This demonstrates that Palo Alto Networks' WildFire can be evaded by both known and unknown malware. Now, should these types of files be miscategorized and introduced to a network, they would be allowed to spread inside the network. Let's see how Check Point's SandBlast solution handles these files. First, we verify the security policy and make sure that threat emulation is activated. And we are using the local SandBlast appliance to perform the emulation. Our protection mode is set to prevent. Now, let's download the file with the known malware, the same file we used in the earlier test, the sample3.pdf. We see SandBlast immediately identified the file as infected and prevented the file from entering the network. Next, let's try to download the file with the unknown malware, makingleaderssuccessful.pdf, which also includes the evasion sample file that uses ROP at the exploit stage. Once again, the file is accurately identified and blocked, preventing it from entering the network. Let's take a closer look at SandBlast to understand how and why it is able to block these files. In the report for the sampled3.pdf file, we can see that this known malware has attempted to gain access to a known infected site, along with other suspicious activities. Thus, the file was deemed malicious by Check Point SandBlast. We can also compare the MD5 hash to verify that it is in fact the same file. Now, let's examine the report for the Making Leaders Successful PDF file. The SandBlast report shows that the file contained an ROP exploit. Therefore, the file was deemed malicious. We can also compare the MD5 hash to verify that this is in fact the same file. Additionally, we can review the malware operation report and confirm that indeed the file contained the ROP exploit, which was correctly identified by SandBlast's CPU level detection. We can also view emulation screenshots to verify the entire flow of this attempted infection process. Unlike competing sandboxing solutions, only Check Point SandBlast can detect CPU level exploits to prevent unknown malware, as well as more accurately detect and prevent known malware from infecting networks.